All right, let's start working our way through this spell work. Looking at the very first parabola, the one over there on the left, what would be the ordered pair for the vertex? 1, -4, right down here. Here's our vertex. Remember, on an ordered pair, it's always the left-right part first, and then the up-down. Axis of symmetry. What letter do you have to make sure to start that with? With an X, yes. We have an X equals equation for our axis of symmetry. Where would we be cutting through? I'm sorry. At 1, yes. We are going to cut through the x-axis right here at 1. And so that's what I need as the rest of my axis of symmetry. Remember, it's not just going to be a 1. If you don't have the x equals at the beginning, it is incorrect. Because this has to be a whole equation of a line. Somebody else should be able to look at this and say, I know where to draw that dotted line at. And without the x equals part, it doesn't mean anything. For the roots, what am I looking at on the graph?
Where it crosses the x-axis?
Yep, where it crosses on the x-axis. So here's the x-axis, and right here and here is where the parabola crosses. So here's one root, and here's the other root. The one that's on the left, what would be the ordered pair for that one? Yes, -1 for the x part, because you go left 1 from the origin, and then you don't go up or down at all, so it's -1, 0. And what about the one on the right side? 3, 0, yes. Awesome. Let's go over to the other parabola. Where is that vertex at? There is a vertex.
3, 1.
3, 1. Right here is our vertex. So 3, 1, which means the axis of symmetry would be where? Give me the whole equation. Yes, sir. X equals 3 is correct. Notice that axis of symmetry is always going to be x equals whatever the x part of this ordered pair is, every single time. So here's our axis of symmetry. What about the roots?
There isn't.
Correct. Yes, sir.
Is one of them 7? Is it 7, 0?
So as I'm looking at this, it has to be where that U shape touches or crosses this x-axis. Does that U shape ever get that low? No. This one doesn't. The other one did. This one does not ever cross that red line because I drew over the x-axis. And so we would say no roots. If it doesn't ever touch across the x-axis, then it has no roots. All right. On Friday, we learned how to graph the parent function. We built the table for that. And then we graphed one more function. We looked at one more that had shifted from the parent. And we looked at our process there where we took those x values, my 5 favorite x's, we substituted them in, and we got the new output for that transformed function. It looked kind of similar, kind of different from the parent. Same basic shape, but the one that we drew second was much skinnier, and it had moved up. So today we're going to talk about how we can use what we know about that basic parent function, and then 3 letters, A, H, and K, to help us graph any parabola we want to graph. So we're going to be on page 57. So there's three pieces. If you notice, this equation right here is written in vertex form. It's got the parentheses, and the parentheses are squared. This is vertex form. And the vertex would be located at the ordered pair H, K. I'm going to talk about those two pieces first, and then we'll talk about that A value out in front. So H is always located inside the parentheses. H is always the opposite, and I'm going to add a word here, sign. It's always the opposite sign of what you see in the parentheses. H shifts the graph left and right. We did this the other day when we were talking about the different forms. To find H, to make sure that you get the correct sign for H, you set the parentheses equal to 0. And if you do that, you will get the correct sign for H each time. What you see in the parentheses will always be the opposite sign, because to find it, you have to set it equal to 0 and solve. Same kind of thing we do with our factors when we factor things and we want to know where the roots are. Things that aren't inside parentheses, like the A and the K in this form, we don't set those equal to 0 because they're not inside parentheses. To remember this, because when I get going, I don't have to set it equal to 0 each time, I call what is inside the parentheses the opposite. Helps me remember that that one always has the opposite sign. I call what is inside the parentheses the opposite. We'll practice looking at a couple things. K, if it is bigger than 0, which way do you think it would shift my graph? H takes it left and right. What do you think K will do to it? Up and down. If it's bigger than 0, do you think it's going to go up or down? It's going to go up.
So kind of like X and Y.
If K is smaller than 0, that means it's a negative number. It's going to shift which way? Down. We didn't actually talk about that with H. We said it's the opposite, and that we have to set it equal to 0 to figure out what it would be. What do you think would shift it left if it's a positive or a negative number? Negative. So after I set it equal to 0 and figure out what H actually is, if it's a negative number, it's going to go left. And if it's a positive number, it's going to go right. Okay. I saved A for the end, and I know this might feel like a lot today, but we use AH and K all this semester. and a good chunk of next semester. So we're going to keep revisiting these ideas over and over and over. AH and K aren't just found when we talk about parabolas. Every single kind of function that we're going to study has a parent function, and we use AH and K with it. My A value. If A is a negative number, if it is smaller than 0, then my graph opens down. If A is bigger than 1, and actually this should have an absolute value around it. So if A is greater than 1, or if A is smaller than -1, then the graph is vertically stretched. It's going to appear narrower or skinnier. When the graph opens down, we say it is reflected over the x-axis. So if A is any kind of negative number, we're going to see this parabola open down. We say it's been reflected over the x-axis. That's what tips it upside down like this. If A is bigger than 1 or smaller than -1, it's going to vertically stretch my graph. So I always think about this one on a number line. If 0 is here and I've got a +1 and a -1, numbers over here will vertically stretch it. Numbers over here will also vertically stretch it, but they will also reflect it. So this is going to be reflected and stretched. All right. And last of all, if A is in between -1 and +1, I don't like the way this is written here. If A is in between -1 and +1 is what we're going to replace that with. So if it's a fraction or a decimal, that is going to vertically compress my graph. What does the word compress mean?
It's wider.
Yes, absolutely, Tito. It's going to squish it, smash it this way. It's going to make it appear wider. Just like, have you guys ever seen those big like exercise balls, like the yoga balls? Mm-hmm. If you sit on those from the top, it squishes it this way, but that mass, that air has to go somewhere. And so it makes it look wider out the bottom. So that's what happens there. Your graph is vertically compressed. Same basic shape, just squished. So the numbers in here will vertically compress it. these a values right in here, if it is a negative decimal or fraction, what do you think will happen to it other than just being compressed? Yep. Yeah, if I have a number that's a decimal or a fraction, but it's a negative decimal or fraction, the decimal or fraction part is going to make it vertically compressed, squished, wider. What will the negative part of that number do to it? Yes. It is going to be really important that we get into the habit of not just saying reflected, but saying reflected over the x-axis. Because later on, not yet, but later on, we'll talk about reflections over the y-axis. So I want to build that habit right now so that we are used to saying and being as specific as we need to be so that when we talk about this other kind of transformation, we don't have to relearn a whole new way of talking about our a value. All right, I realize that is a lot up on the screen. We're going to start to practice with this. Make some sense of all of these directions here. All right, let's look down at number 1 there. Before I switch screens, is there anybody that needs me to leave it here for just another minute or so? I want to make sure everybody has a chance to write this down. Like I said, this is really, really important, not just for today, not just for this unit, but for pretty much the rest of this semester and a good chunk of next semester. We'll be talking about AH and K over and over and over and over and over. All right. So this problem right here. If I had this parabola graphed, y equals 2, and then inside the parentheses we have x minus 4 squared plus 3. Can you tell me which piece is A? Yep. The 2. Here's my a value. So I know compared to the parent, this has been vertically, what? Vertically stretched. Any numbers on the number line that are farther away from 0 than a 1 or a negative 1. So if you're not a decimal or a fraction, it's going to stretch it. Even if it's negative, it'll still stretch it. Which one of the 2 numbers left is K? 3 right here. And what does K do to things again? K takes things up and down. H is the one that takes things left and right. And the way I remember that one, it's always inside the parentheses with X. And which way does the x-axis go? Yep. X-axis goes left and right. And so if it's inside the parentheses with X, it's going to affect it that way. Is negative 4 my H value?
Yeah. Don't you have to switch the sign?
Yes. This right here is not H. What I see here is what I call the opposite. To find what H actually is, I need to take x minus 4, and I need to set it equal to 0. So then I would add 4 to both sides. So what is the actual H value? 4. Compared to the parent, which way has this been shifted? If H is a positive 4. To the right 4 units, yes. Okay, so this is my starting place. Remember, this is in vertex form. From vertex form, I can tell what the vertex is. My vertex is going to be HK. So what would the ordered pair for this vertex be?
4 and 3.
Yep. 4 and 3. You're correct. This is going to be my H and my K. H here, K here. All right. This graph right here with this vertex, we're going to take it and we are going to shift it 5 units to the right. Which of these two numbers, the 4 or the 3, is going to change if I shift this 5 units to the right? H is going to change. So to find the new vertex, I take the original vertex, 4, 3, and I'm going to add 5 to that. And what else did it say is going to happen to this? It's going to shift 2 units down. Which of these two numbers is that going to affect? The K value, the 3. Am I going to add or subtract it? Subtract it. This is going to move it down 2. All right, so I'm actually going to combine those things together to get my new vertex. What is 4 plus 5? 9. 3 minus 2? 1. This is the new vertex. Did anything else change about it? Did it say it got skinnier or reflected at all?
No.
Then my A value wouldn't change. So I'm going to write the new equation. It's going to be a y equals equation. The A value didn't change, so I still have a 2 here. I have x inside the parentheses, and the parentheses get squared. What number am I going to have in there with x?
Plus 9.
What do we have to remember about when it's inside the parentheses?
Opposite side.
It's the opposite sign. So what this is telling me right here is that x equals 9. If I want to figure out what goes inside the parentheses, I have to get this set equal to 0. So I would subtract 9 from both sides. X minus 9 is what goes inside my parentheses. What goes inside the parentheses is always the opposite sign. And what should go on the very end?
Plus 1.
Plus 1. My positive 1 right back here. We'll practice with some more like this, but not right this second. I want to look at the graph down there that's number 2. Looking at this graph, what is the vertex of this graph? 1, negative 4, because we do our x part first, the left, right, and then we do the up, down part. So 1, negative 4. The equation written in vertex form. Vertex form is that one up at the top of the page with the A, the H, and the K. We are going to assume that our A value is 1 here. The directions should always tell you whether you should make this assumption or not, but we're going to assume that my a value is 1. If my a value is 1 and I'm going to multiply that to something, do I need to write the 1 there? Like, do you need to write 1x? Yeah. We don't have to put the a value there if it's just a 1. All right, I know inside the parentheses I need an x. What do you guys think is going to go inside the parentheses with the x? Close. Am I looking at the x part or the y part? Yeah, I'm looking at this for my h value. So I would take that and set it equal to x. And then I have to get it equal to 0. So I would subtract 1 from both sides. I would get x minus 1 inside those parentheses. Because remember, what I see in here is the opposite. What would go on the end? Minus 4. This is my k value, and I just lift it straight from here. So if it's gone to the right, what I'm going to see inside the parentheses is a minus. If it's gone to the left, what I'm going to see inside my parentheses is a plus. Because when I take the part of the vertex, the x part, and I set that equal to x, and then I get it equal to 0, it's always going to be flipping the sign there. All right. Go ahead and flip the page for me. There we go. Okay. We're going to look at these tables, and we're going to use words to describe the transformation. Which way does the x-axis go? Does the x-axis go left and right, or does it go up and down? X goes left and right. Yep. Okay, so here's my x-axis. Here's my y-axis. I'm going to look just at the x column here. This is my original function. And this is my transformed function. All of the x's in the first column have been transformed in the same way to give me the x's in the other table. So if I started at 1 on the x-axis, and then I moved that point over to 3, which way did I go? Right. How far right? 2 times. If I go from 2 originally, and then I move it to 4, which way have we gone? Right. How far? Yep. Right 2. This has moved right 2. Because 1 plus 2 is how I get this 3. 2 plus 2 is how I get this 4. So we went to the right 2. This other column that says f of x and g of x, this is just the same thing as y. That's function notation that they're using, but they're talking about the y parts of these ordered pairs. So now I'm looking at the y column on my original table, and I'm looking at the y column on my transformed table. What do you notice about those 2 columns? They're exactly the same. So did this move up or down at all?
No.
Nope. There's no change here. So if I wanted to know my k value, k would be 0. If I go right 2, then h is 2. Look at this second set of tables, number 2 over here. Yes, sir. Mm-hmm.
Okay. H would be 0 and K would be 4.
Yes. Tell me how you know that.
Because the first one, they don't move at all, and the second pair, they, well, the second
No, you were right the first time. Yep. When x changes, we go left and right. When the second column changes, the y column, we're going up and down. Yep. Absolutely correct. So right here, we have no change between these two. I need to make that a little bit bigger.
So for the transformation, we just put 0 then up 4?
You don't even have to put the 0 part. Because when we talk about transformations, we're talking about things that are different. And since there was no change there, nothing is different between those values. That's a great question. Right here, absolutely correct when you said up 4. Because if I add 4 to this, that's what gives me this 6. If I add 4 to the 8, that gives me the 12. And that should work for every single piece there. So this went up 4. So my k value is 4. All right. There's only one more thing that I want to look at with you guys today. Down at the bottom of the page. Oh, I'm sorry. I can go right back. My apologies. Down at the bottom of the page, we have several equations that are written in vertex form. And we want to use words to describe how these equations would look different from the parent if I were to graph them. So I want to describe their movements. I want to say whether it's narrower or wider. I want to say whether it's pointing down versus pointing up. That would be reflected. Did it go left or right at all? Did it go up or down at all? Because I know it's going to have that same basic U shape to it. All right. You guys okay if I switch the screen? Yeah. Okay. I just don't want to move on too fast. Thank you for saying something when I did. All right, so I'm going to write transformation form, vertex form up at the top. I always use this just like it's a map so that I can read these equations. Let's start with the middle one, with B, because that looks the most like this. I've got 3 numbers there, and I have 3 things that I need to identify, my A, my H, and my K. What do you guys think the A value is? -2. When my A is a -2, a couple things happen. The negative affects it, and then the 2 affects it. What do you think the negative part of the number will do? Yep. This is going to reflect it over or across the x-axis. The 2, is that a decimal or a fraction?
No.
Decimals and fractions are what compress it. They'll squish it. If it's not a decimal or a fraction, what's it going to do to it? It's going to stretch it. So this will be vertically stretched by 2. Let's talk about K next. Which one of those 2 remaining numbers is K? The -7. This is K. Sorry. Which direction will K move things?
Yeah.
Yep, K takes things up or down. You'll get it, I promise. If it's a -7, which way do you think it has shifted? Down, yes. This went down 7. And then the last thing I need to find is what? The H. I see this here. I know that's not H, but it's very close to H. It's going to have the opposite sign of H. To find what H is, I take what's inside the parentheses and I set it equal to 0. And then I solve for x by doing what?
You like to add
Mm-hmm.
And then you do the same thing to both sides.
Yes. So am I adding or subtracting here?
Adding.
I'm going to add 3 to both sides because it's a negative 3. So h equals 3, or sorry, x equals 3. That is my h value. H shifts things which way? Left and right. If it's a positive 3, which way am I going? Right.
All these variables are very confusing.
I know. But like I said, we're going to use this over and over and over and over and over until I guarantee you by October, November, December, you're going to be like, oh, it's A, H, and K. This is an easy day because we'll do it so much. Yes, ma'am.
Like on our test, when we're describing transformations, do you want us to write like the units, like for example, like for the h value and k value, it's like either shifts up and down or like side to side. Do you want us to write like so you know how it goes down 7?
Mm-hmm.
Put down 7 units.
If you put down 7 units, that's perfectly fine, but I don't require that. If you tell me down 7, I would be okay with that because I understand that means counting along the number line there.
Okay.
Good question. All right, let's do these other 2 real quick. When I look at A, do you see parentheses?
No.
No. So that 4 in front, who do you think that 4 is, A, H, or K? If it's in front of my x squared and it's not inside parentheses, would that be A, would that be H, or would that be K? A. My A value always comes right after the equal sign, and it will never be inside parentheses. Who do you think this is back here? Again, it's not inside parentheses. K. So what is H? 0. H equals 0. That means it's not going to go left or right at all. There's no change there. An A value of 4, what will that do to my graph? It's going to be vertically stretched. It won't reflect it because it's not negative, but it will vertically stretch it. I would say that it's vertically stretched by 4. K is a positive 3. H is what takes things left and right because H is there with X. So K takes things up or down. Which way is this one going?
Up.
Yep. We are going up 3. Last one, and we'll call it a day. On part C, do I have parentheses?
Yes.
Yes. I only have 2 numbers here, so who's missing? K. There's no K, and so K is 0. This 3/4 right here, who is that then? Is that A or H? A. Is 3/4 smaller than 1? So is that going to stretch it or compress it? Compress it. We are going to be vertically compressed by 3/4. What is my H value? 2. Because I take x minus 2, I set it equal to 0, and then I solve. That tells me what my H is. If H is a positive 2, are we going left or right? Right. Wonderful. Fantastic, guys. I'll turn the announcements on here in a minute. Our classroom announcements. Unit 2 test is Friday, September 17th. Homework number 2 Homework number 2 is due by tomorrow morning. I want you guys to practice with this transformation stuff. It is really important that you get in and you look back at your notes and you practice with this because it is so important to the course overall.